Hey students, I am on campus today. I am just helping, or I'm observing some other math teachers on site here. So if you need help with anything, I will be here after school. What you need for today is a piece of graph paper. So if you don't have a piece of graph paper, pause this, go get a piece of graph paper and come on back. You're gonna need it to be graph paper because you will be doing at least one graph on this piece of paper. All right, if you have your graph paper already, I want you to fold it into fourths. Okay, and then the corner piece right here where it all comes together, fold it down like a potato chip. So that it's like, hello, hello. Okay, so when you open it up, then you're gonna have this like a diamond shape in the middle. That's what you want. I'm gonna darken up my lines because it will make it easier for me to see where all the lines are. You can do that as well as if you would like. What we're doing today is I'm only gonna do one example for solving by substitution because I think that you all are gonna be just fine on it. But if not, you're welcome to come in after school, ask me tomorrow, ask your friends. But I think you are only gonna need one example to understand. Okay, so you are going to be able to use this piece of paper on your quiz. Your quiz is next Wednesday. So what we're going to do on this piece of paper is we're going to put a different method in each box for solving systems. Okay, so in the middle we can just title this. This is solving systems of equations. Okay, last week the very first method that we did was graphing. Okay, so graphing was our first method, and let's do a quick example of that just to refresh our memories. Let's use this system of equations. Y is equal to negative 3x plus 1, and 2x minus y is equal to negative 6. So I'm going to create my graph here, my coordinate plane. I'm making it as big as I can just because we do have a y-intercept of negative 6 on that. Actually, I don't know that that's the y-intercept yet. We'll find out. Okay. I suppose I should have solved for y on this one before I made my coordinate plane, but that's okay. Let's go ahead and graph that first equation because it's already solved for y. So I'm going to plot my y-intercept at 1. My slope is negative 3, so I'll go down 3 over 1, down 3 over 1, and draw my line. Now, in truth, I probably would not have chosen, if I had a choice, to do graphing for this problem because it's set up nicely for substitution. We know that y is equal to negative 3x plus 1, so we could just plug that in for y and solve it. But I wanted to show you what it's like when it's not solved for y. So we're actually gonna have to do that work. So I'm gonna take the equation over here off to the side, that's x. And I'm gonna go ahead and solve for y so that it makes graphing much easier when it's solved for y because then I can use the slope and the y-intercept. Okay, I'm going to divide both sides by negative 1 to get rid of this negative right here. Basically, when you take that negative away, all the signs here are going to switch. So this will be negative 2 or positive 2x plus 6. And like I said, I left a bunch of space down here because I was thinking my y-intercept was going to be negative 6, but it's actually positive 6 when I solved for y. So I'm going to put a point up here at 6, And my slope is 2, so I'm actually going to go up 2 over 1. So we're going to have to backtrack a little bit too. I can already see where they're going to cross. So when you run out of space, you just have to go the other direction. Okay, so here's our solution. That point is your x is -1, your y is 4. I'm going to do a little bit of checking here just to make sure. It needs to work in both equations, and you want to use the original equation just in case you made a mistake when you were solving for y. So this is 4 is equal to -3 times 1 plus 1. Oh, she plugged in -1, sorry about that. I'm thinking one step ahead and it's messing me up. Okay, so that worked. And now I'm gonna plug it into that second equation, again, making sure it's the original one, not the one where you solve for y, just in case. Yeah, we're good. Okay, so I know that this is the solution to my system of linear equations. Okay, now let's talk about that next method we used. That was the equal values method. Okay, I'm going to use this system. This is set up very nicely for equal values. You're only going to use equal values if it's already solved for both equations are solved for the same variable. That's the only time it makes sense. Okay, since I know this whole thing is equal to y and this whole thing is equal to y, then they have to be equal to each other. So I'm going to go ahead and set these two expressions equal to each other. Okay, I'm going to subtract 2x from both sides. X minus 25 is equal to -18. Add 25 to both sides. And I'm getting that x is equal to +7. I'm going to take that, and it doesn't matter which one I plug it into. I'll just plug it in right there. And then I'm going to go ahead and solve for y. So this will be 3 times 7 minus 25. Okay, so I'm getting that y is equal to -4. So that means my solution should be the point 7, -4. I'm just going to double check it though. I used this first equation to find y, so I'm going to use the second equation to check it. Yeah. Looks good. Okay. Our last method, we started talking about it yesterday. But it's not always going to be, you're not always going to be given a system where one of your equations is already solved for a variable. So I'm going to show you in this example here what happens when it is not solved for a variable. Okay, so this is substitution. All right, so we're going to use this system of linear equations right here for this one. Okay, so you're going to see that neither of those two equations are solved for a variable, but you guys know how to solve for a variable now. We have spent a lot of time on it over the last couple of days. So you can do a couple different things here. I would recommend either solving for x right here by adding 3y to both sides, or solving for y here by adding 2x to both sides. Either way, you're going to get your equation solved for a variable. Okay, I'm going to stick with that first one right here. So I'm going to take this equation and I'm just going to solve for x. You just want to pick a variable that's going to be easy to solve for. And solving for x is pretty simple here. So we're going to get x is equal to 3y minus 9. Okay, now that you know the value of x, you're going to take that value, this whole thing, and you're going to plug it into the equation here for x. We don't want to plug it in up here because that's the same equation we just did when we solved for y, or solved for x. So let's go ahead and rewrite this now, and instead of x, I'm going to write 3y minus 9. And do make sure that you are using parentheses. If you do not use parentheses, you are going to have problems, as I'm sure you saw on your homework last night. This is negative 6y plus 18 plus y is equal to negative 2. I am regretting not shutting my door before I recorded this. People are being loud outside. I don't know if you can hear them or not. Okay, so remember, whenever you're doing a multi-step equation, you distribute first, always. Then you combine like terms. Then you solve for your variable. And when you're solving for your variable, you always add or subtract first, and then you multiply or divide. I think some people are forgetting that. Okay, so I'm going to go ahead and do that. I get negative 5y is equal to negative 20. Divide both sides by negative 5, and I get that y is equal to 4. Here's my first piece of information. Now, like over here when we did the equal values method, we don't want to plug it back into this, or we want to just pick one of the equations to plug it in for. I'm going to go ahead and do that one. So that means I'm going to have x minus 3. Instead of y, I'm going to do 4 here. This may be the same problem that we did either on the homework or in class yesterday, but that's okay. It's nice to see it in a different light. Okay, we're going to add 12 to both sides, and we get that x is equal to 3. Okay, so now we have both pieces of information here. So we can say that the ordered pair is 3, 4. And like always, I'm going to check it. I'm going to check it in the equation that I didn't use to find x. So this will be negative 2 times 3 plus 4 is equal to negative 2. I can already tell that it's going to work, but I just want to be thorough here. Yep, we're good. So that is your solution. Now, you're probably wondering what that fourth box is. Okay. This method is called elimination. And I do not teach this in this class. You will learn this next year with Miss M in IM 1. But if you feel so inclined, you are welcome to search up how to solve systems of linear equations using the elimination method. They have a lot of great videos online, and Khan Academy has some. So if you're interested, feel free. I just wanted you to know that there's another method, but we will not be talking about it in this class. All right, so your homework tonight is in Otis, and it's going to be problems that are substitution based. And you have the answer checker. Remember, you need to get them all correct. If you cannot get them all correct, you need to email me and let me know. And remember, you're putting in an ordered pair with no spaces, and don't forget your parentheses and comma. All right, send me an email if you guys need anything, and I will see you tomorrow or after school today.